Hi everyone, welcome to Techie. As many of you asked for Kafka Streams, I am kicking off a brand new series. In this series, we'll go step by step from understanding what and why Kafka Stream to building real-time data processing pipelines. And we'll also explore different Kafka Stream operation, all with Spring Boot hands-on example. Okay? So if you already know how Kafka producer and consumer work, then this series will take you to the next level. You'll learn how to process, transform, and enrich the data on the fly using Kafka Streams. As always, I'll keep it practical and easy to follow. So by the end, you'll have a complete real-time understanding from zero to advanced. Okay? Alright. So let's begin with the very basic. What is Kafka Stream and why do we need it? That is the first thing we should know before start working with Kafka Stream. Okay? So let's get started. If you have already worked with Kafka producer and consumers, then you probably know how great Kafka is for moving data between microservices, right? You have got your producer, they publish or write event to the topic, and then you also have your consumer who listen or read from that topic and process those events. Simple enough, right? Now you might have a question, since we already have Kafka who easily handle streams of data so well, then why do we need even this Kafka stream? Is this something a new feature or is this something a new framework? That's really a good question. So instead of giving a boring theoretical definition, let me walk you through a real world use case that clearly show you how Kafka Streams solves real time problem, or that will give you the clear picture why do we need Kafka Stream in real time. Now imagine this, you are working at a food delivery company like Swiggy or Zomato. Every few seconds, thousands of delivery updates are flying into your Kafka topic like order accepted, order picked up, or order delivered. Okay, so you have got a consumer application that continuously process these events. Simple, right? Now one day, my manager asked me, "Hey, can you design a real-time delivery progress dashboard? Something that shows how many orders are active, how many orders are delayed, or how many orders are delivered, and it should auto update in every minutes or maybe in every hour or even every day, something like this. You should create a dashboard, and dashboard should display the count of active, delayed, and delivered order." Now, being a smart developer, I confidently said, "Yes, I can do it. It's dead easy." Because initially I thought I have a Kafka consumer, so I will start reading messages from the topic and push them to the dashboard by writing some custom aggregation logic. But here are the challenges I faced when I started working on it. I realized my consumer has a stateless in nature. Stateless meaning it does not remember what happened before. For example, let's assume I have these three events A, B, and C. Okay. Now, when my consumer is consume the event A, now again when I consume event B, then I don't remember what was there in event A. Similarly, by the time event C comes, event B is also gone from memory. Usually I don't keep state of my previous event in my consumer code. That's the real problem. Then how do you calculate things like active, delayed or delivered order if your consumer can't even remember the previous event? Because to aggregate, filter or join the events, you need to maintain a state to evaluate results like total counts. Then only you can display that number in the dashboard, right? So it's really difficult to design using plain Kafka. You would have to manually handle a bunch of things like once you consume the event, you need to update the database. Next, you need to maintain and aggregate the count like how many are active, delayed and delivered. Then you also need to cache them to avoid multiple DB hits. And also the tricky part, you need to write the query which will hit your DB, get the records and push it to the dashboard continuously either using WebSocket or server side event. You need to implement any logic to auto update your dashboard. Okay, looks too complex, right? Something like this. If you check the code, you are writing the records to the DB. Then you have written the query to fetch by status, how many are active, delayed, and delivered. Then you put them into the cache as a in-memory storage. Then you broadcast that to the dashboard by using WebSocket or server-side event or any streaming mechanism. And mostly, if you see the pseudocode, we end up writing tons of extra code just to handle the state, aggregation, and data consistency. And it does not stop here. You also have to carefully manage the offset, otherwise, you risk losing the messages or processing duplicates, especially during the crashes or Kafka rebalance. Then comes the thread safety and scaling header. Creating multiple consumers, assigning partitions manually, ensuring everything runs in sync is really difficult if you handle it manually, right? All this drama we are just doing to enrich or aggregate messages in real time. That's really too painful to handle using plain Kafka consumers, isn't it? Because you need to write the bunch of code, you need to handle the offset manually, you need to deal with scaling and thread management. So that's really a difficult task if you want to design that using plain Kafka consumers. Now the question is, how do we fix this mess? How we can overcome this? Well, that's exactly where Kafka Streams comes into the picture. Now, what does the Kafka Stream do here? Once your producer send events to the topic, this Kafka Stream application subscribe to the topic and read the data. Then it process, aggregate and enrich the data in real time. Then finally, it write the transformed data back to the topic. Okay, how simple is this, isn't it? Just three steps, and you can handle even the most complex real-time data enrichment logic on the fly. Your Kafka Stream application simply read the event from topic, then it did the data enrichment, then it write back to the destination. That's the simple flow of Kafka Stream application. So don't worry about how all this magic works internally. We'll dive deep into that in my upcoming videos when we'll start writing the code using Kafka Stream app. Okay, but at high level, Kafka Stream design with multiple processor, source processor, read data from the source topic, stream processor who process or enrich the data, then sync processor who write the result back to the destination topic, and all three processor together called as a single topology in Kafka Stream. That's it. As simple as that. So now you have got a basic idea of what Kafka Stream is and why we need it. So I don't think I need to give you the definition to understand what is Kafka Stream now. Okay? If you are with me, next let's explore the API that Kafka Stream provide to work with these processor and build real-time data pipelines. Basically, Kafka Streams give you two main API, Stream DSL and Processor API. So this Stream DSL is most commonly used. It's the declarative way to design your Kafka Stream application. You define what to do and streams handle the how. How to do it, that will be handled by this Kafka Stream. And you need to mostly play with Stream Builder, KStream, KTable. Okay. Again, you no need to worry about these terms. We'll understand everything in details in my upcoming videos. Okay. Next one is the processor API, which is a low level API. You will have the more control on this approach, but you need to write more boilerplate code and you need to manually create the processor and topology. All these things you need to write manually. Okay. However, the Stream DSL is just abstract on top of processor API where you can simply define what to do and how part will be taken care by this Kafka Stream. You no need to hit your head to understand how to create processor, how to create topology if you are using Stream DSL high level API. Again, I repeat, You no need to get tense by hearing this particular terminology. You will understand everything in details. Before we jump into the coding part, let's do a quick recap of how the Kafka stream flow actually works. Once your producer application sends event to the topic, Kafka streams take over. Now what it does, your Kafka stream subscribe to the topic and read the incoming data or events. Then it process or aggregate or enrich the data in real time. And finally, it write the transformed data back to the another topic or the same destination topic. Super simple, right? Just three steps: read, process, and write. Trust me, once you understand this high level flow, Kafka streams will feel super easy for you. Okay, now let's focus on today's use case, what we are going to develop. Imagine you are working on a banking application and you are being assigned to design a fraud detection system. Your application is continuously receiving a stream of transaction events, and your job is very simple. You need to filter out those transactions which exceed some threshold. For example, let's say 10,000. Then you need to figure out those transactions who exceed 10,000, then mark it as a suspicious transaction or trigger an alert. This is the simple task you need to do. Now the question here, how do we design this? It's actually pretty simple. Let me walk you through how we can build this flow using Kafka Stream approach. Okay, let's say your producer application is sending a continuous stream of transaction event to a Kafka topic called transactions. Now our Kafka Stream application comes into the picture. What it does, it reads those transaction events from the transaction topic, then it filter out any transaction where the amount is greater than 10,000, and finally it write those filtered suspicious transaction to another topic called fraud alert. Now you could have other consumer application like notification service or account locking service which will listen to this fraud alert topic and do the necessary action. Simple, right? Just a clean and easy use case to start with Kafka Stream. So let's begin with the basic fraud detection flow, and in the upcoming videos we'll extend it to handle more real-time complex scenarios. Okay? Alright. Then let's see it in action. So to save our time, already I created a simple application where it will just publish the transaction event to the topic, and as part of the dependency I have added Spring Web, Lombok dependency, then I have added Spring for Apache Kafka and Spring for Apache Kafka Streams. Okay, so basically you need this Spring for Apache Kafka dependency only if you are writing the producer and consumer using Kafka. Okay, but if you want to play with Kafka Stream, this is not required. But as per our use case, we need a producer application who will publish bunch of transaction events to this particular transaction topic. Then we have this Kafka Stream application who will process that record. Okay, so the first part already I designed where producer publish the event to the topic using Spring Boot. So I don't want to repeat this example since we have done multiple Spring Boot Kafka example. So I hope you already aware about it. If not, I will share the Kafka playlist link. You can check that out. Now let's open IntelliJ IDEA. You can see already I created a template. Now if you check the pom.xml, we are using latest Spring Boot version and we are using JDK21. Going forward in whole series, we will use this JDK21. Then as part of the dependency, we have added web, Kafka Stream, Spring Kafka. Then I also added the Swagger. Okay. Then we have Lombok dependency. That's it. Now what I did here, I have created a Kafka config where I have write a bean to create a transactions topic. Okay. Now I also define a transaction controller. What it does, it just have a simple endpoint to publish couple of transaction object or transaction object string to the Kafka topic. Okay. Now if you see here, I have created a loop of 10 object and transaction ID will be generated dynamically, and amount will be generated within 8,000 to 11,000, and this is what the object I am building. I am converting them to the string, then I am sending to the Kafka topic called transactions. Okay, that is the simple logic producer application I have designed. And if you see the application.yml, I have defined the Kafka producer configuration, where I have defined just the bootstrap server and the key serializer and value serializer. For this initial demo, I am using key serializer and value serializer as a string serializer. Okay, that is the simple producer application we have designed. Now, what is our next task? If you understand the flow, our next task, once the event reaches to this transactions topic, then we want to use the Kafka Stream app to read it, process it, and write it. Okay, so for that, what you need to do? First, you need to define the Kafka Stream configuration. So the configuration is very minimal. Now, what you need to do? You need to define stream, then you can define the application ID, give some meaningful name, fraud detection streams, you can give any name. Then the next part, you need to define the properties for serializer and deserializer. Okay, so you can say default dot key dot, okay, default dot key serde, which means serializer and deserializer. Now what is that? That is, we are going to use the string here. So just define org.apache Kafka common serialization serdis and string serialization. Okay, so for this demo we are using string. In upcoming class I will explain how you can use your custom serializer and deserializer. Fine. Similar way, let's define the value. So define value serializer. Okay, so again, currently we are using string, but in upcoming videos we will cover our custom serializer and deserializer. That's the minimal configuration you need to add for Kafka Stream. That's it. Now what is our next step? We need to define a Kafka Stream application who will read the events from this transaction topic. Then we need to write a processor who will filter out all the transaction if it exceed 10,000. Then third step, we need to write it to another topic. Okay, so let's create this Kafka Stream application. So to create this Kafka Stream application, what you can do? Let me create another package. Let's say stream. Then I'll create a Java class. Then I'll name it fraud detection stream. Simply nothing to do. The very simple step you need to define here. Annotate @configuration. Then you need to enable Kafka Streams. Okay, since I have added Lombok, I will just add the SL4J for logging purpose. Okay, now what is the next step? Here I need to create a bean. Inside that bean, I'll tell to that bean by defining couple of Kafka Stream DSL logic. Read the topic. Then what is the next? Process or filter. Then write to the destination. This is the three things I need to define to my Kafka Stream bean. So let me create a bean public who will return me the Kafka Stream. Since we are using string serializer and deserializer, let's use the string for now. Key and value as a string. Then define a method called fraud detect stream. Next, we need to pass the stream builder object here so that we can create the Kafka Stream object. Fine. Now what is the first step? Read message from the input topic. Now you have the builder. What you can do? Tell to the builder, hey, this is my input topic. What is that? Transactions. You read from this topic. What you need to read? You need to read Kafka Stream of key as a string, value as a string. Define the variable name. I will define transactions stream. Okay. Is this clear? The first step, we are telling to the builder just read from this particular topic. Now what is the next step? We need to filter out all the transaction if it exceed 10,000 or some threshold you can keep. So you can simply define like this. Okay, the second step, process the stream to detect fraud transaction. Now you already have the transaction stream. Use that transaction stream dot you do the filter. Okay, as part of filter, what you will find? You will find the key and value. Whatever you will get in the topic, key and value. Then here you need to what you need to do? You have the value, convert it to the object, or from the string JSON, just get that node and figure out if that transaction object has the value or amount if it is greater than 10,000. So what I will do to make it more simple, I will define a private method. Okay, so in this particular methods, what I am doing, I am using the object mapper to convert the Kafka message to the object, which is nothing the transaction object, and I am checking if transaction amount greater than 10,000. These things you can configure dynamically, but for testing purpose, I am using the 10,000 limit. So you could also do it 1 lakh. Okay, but for demo, let it 10,000. So if any transaction amount exceed than 10,000, then this will return true, and this will be marked as a suspicious transaction. So you can simply use that is suspicious, give the value which is nothing the Kafka message you are getting, make it small lowercase, then you can simply print that. You can use pick, fine, and again you will have the key and value, then just add some log statement. I am adding this one, log.warning fraud alert, transaction ID is this and value is this. That's it. Okay, this is the step 2. See, whatever we have discussed in theory, I am following the same step as it is. The first step, we read from the source topic, that is transactions. Second step, in the Kafka Stream app, we wrote the logic to filter it. Then we will go with the third step to write it back to the another topic or some destination topic. So what you can do, that is very simple. You have this transaction stream, whatever the fraud transaction you found, you can name it. Actually you can name it, better define a variable. Just define fraud transaction stream, then those fraud transaction stream you want to write it to where? Another topic called fraud alerts. Okay, anything you can give. Now I will just return the source stream, I mean the original stream. Did we follow all the 3 steps? Just add a comment. All the 3 steps we write it properly, step by step. Okay, so since I am explaining this for better understanding, we are using different stream variable for each action, right? But if you want to simplify this using Java 8 functional style coding, you can also do that. We'll use this approach, okay, which will easy to understand for beginners. Now what I need to do, I need to define this as a @bin. Now what we are doing here, reading from transactions, doing the filter, then writing it to another topic. So we also need to create this particular topic. Now we have the Java based approach to create the topic. I will copy this and I will write create transaction topic, not I will change it to create fraud. I will perfectly copy this, change it. All these 2 topic, I no need to create it manually. I have defined the new topic from Spring Kafka, which will create the topic for me. All good? How simple is this to just process the data at real time? Currently we are just doing the read and write operation kind of scenario, right? But Kafka Stream has lot many advanced features. It's not meant for only read and write. That we'll discuss slowly, but this is what the approach you can play with Kafka Stream the basic flow to understand Kafka stream. All good. Now what I can do, I will also change here. Okay, let's not send 10 object. I'll send 50 request. Out of 50, we will find couple of transaction object which will exceed greater than 10,000, so that my Kafka stream will filter them, and currently we are logging it. If you understand the flow, we have this fraud alert topic, right? We are also writing to the fraud alert topic here. After that, you can define multiple consumer to read it from the fraud alert topic and do the needful action. Okay, that's we are not going to do. Let's not make the things complex. Let's understand the Kafka stream basic flow. All good. Now what I need to do, I need to start my Zookeeper and Kafka server. Let me start both. All good. Now let me also start my Spring Boot application. Go to the main class, just run it. It will run on port 9191. Okay, so it started. Let me zoom this. Can you see here? See the state transition from rebalancing to running. If you will find any error, the state will change to the error. That is how Kafka stream internally maintain the state in rocks DB. Now what we need to do, let me clear this. Okay, let me open the Swagger. Now we have these API transactions. Now try it out. What it does, see the flow again. I am repeating again and again because I want you guys to be clear on this Kafka stream flow. This is the first demo. Going forward, we'll go into the complex scenario. Okay, so we'll send event to this particular topic. Then our Kafka stream application comes into the picture. It will read, process, and write. Okay, let's validate that in the log. Now execute the request. It will trigger 50 requests, right? Out of 50, how many are eligible for fraud or suspicious transaction? See here. Let me filter it, right? We have trigger 50 events to the Kafka transaction topic. Out of that, how many? 18. 18's transaction having amount greater than 10,000. See here. All are greater than 10,000. Now rest 40, not 42, 32 is the correct transaction data. Okay, now to validate that, what I will do, I will just open the offset explorer where you can visualize the events in the topic. Now let me open that. How many topics we have? Transactions and fraud alerts. So in transactions, you will find 50 events. Okay, total 50 events. Now in fraud alerts, if you will run it, you will find total 18. You can count them, but see, it went to different partition. 1, 0, 2. We have created 3 partition. All the event equally distributed to different partition. That is another beauty of Kafka stream. So if you see here, all the transaction what you are seeing here is greater than 10,000. You can set some threshold and you can validate it. Now it's interesting, right? Using Kafka string, by writing just 3 lines, we are able to filter real-time data. I believe you got some context on Kafka stream basic flow. Now you might have a question, hey, why do we need this Kafka stream application? I could simply create a consumer application here like this, and who can simply listen to this Kafka topic, filter out all the transactions who exceed 10,000, then write it to the fraud alert topic. I can write 3-4 line additional code to do it in Kafka consumer, directly in plain Kafka consumer. Why do I need even this Kafka stream? And this is really an excellent question. And this is exactly where most developers get confused initially when comparing the Kafka stream versus plain Kafka consumer producer logic. Okay. At first view, our observation is right. We can do that using Kafka consumer as well. But the real value of Kafka stream comes not from this simple read and write data flow example. It's in how it processes the data, what guarantees it provides, and how much complexity it saves you when building the stateful, scalable, and fault tolerant streaming application. Okay? Alright. Don't stress, just be patient. All your doubts will make sense once we dive deeper into more scenarios. For now, don't overload your little brain. Just focus on understanding how the Kafka stream flow works. Try with different scenario, try with different example. So far, we have tried a simple fraud detection system, but Kafka Stream has many more powerful features that can make our example more real time and dynamic. So, before we dive deeper, it's always important to strong our basic. In the previous example, if you remember, we played with all string data, but what if we want to work with object? How will Kafka serialize and deserialize them? How can you tell Kafka Stream which serializer or deserializer to use? Remember, if you mess this up, your streams can break. So we have tried this particular example in our last video where we are consuming the string of events. If you see the parameter and if you go and check in your controller class, we are just creating the object, then we are converting it to the JSON string, then we are sending that JSON string to this transactions topic. Then from the transaction topic, our Kafka stream will filter the fraud alerts based on the condition what we have defined. Then again, it write back to another topic in the form of string. Correct? Now, what if I don't want to play with the string, rather I want to play with the actual object? Now the question here, how can you teach to your Kafka stream to deal with this particular object? Or how can you define the serializer and deserializer? So in Kafka stream term, it is called SERDES. Okay, it is nothing the prefix of serializer and deserializer. SERDE. It is up to you how you want to pronounce whether serializer and deserializer or just SERDES in Kafka stream. Okay, let's do modification in our code to use object instead of string. So now at first step, we need to stop sending string data to the transactions topic. Okay, so if you remember the flow from the producer application, we are sending string data to this particular topic. Then our Kafka stream read that string and write it back as a string to this fraud alert topic. Okay, so first stop sending string from here, and this Kafka template now send what? This particular transaction object. So you also need to change the Kafka template to map the value as a transaction object. Next, you also need to define in your application.yml what value serializer you have defined while producing the messages string, right? Just change it to JSON serializer. org Spring Framework Kafka support serializer and JSON serializer. Okay. Now our producer is done. He will not send string. What he will send? He will send direct transaction object to this particular topic. Now who will process after that? Our Kafka stream. Now go to the Kafka stream code. Here what you can do? You can tell this Kafka stream to not use string, use the transaction object directly. So what you can do? You can create the variable, let's say transaction SERDE. Then you can use new JSON SERDE and you can define the object type, not here. Now you can use this particular transaction serializer deserializer to use the object as a value. Okay, so what we'll do, I'll just comment this whole code. We'll also use the functional style coding using Java 8. Okay, so at first place, what is our task? We need to read from the input topic. So I will use the builder dot stream, give the topic name transactions, then which type of input and output you are getting, key as a string, value as a transaction object. So you can define consumed with, you can define our own studies, whatever we have created. You can just define like this. What it will return to you? It will return you KStream of key as a string and value as a transaction object. Are you good here? Fine. Now what is the next step? Let me, yeah. Now what is the next step? You have this stream. Now you need to write this particular logic to filter out fraud alerts. Okay. Let's do that in functional style coding. You have the streams. What next? You just need to filter out the key and value, and from value you need to figure out if transaction exceed greater than 10,000 or not. So you have the key and value. Better instead of value you can define this as a transaction. Okay, because now as a value you will get the direct object. So what you need to do here, transaction dot amount, if it is greater than 10,000 then filter that record. What next you want to do? I want to just print the statement for debug purpose for this demo. Otherwise, as I already explained, you can have multiple consumer to process the record. Okay, so what I'll do, I will just add a sysout or some log statement. Better I will copy this, then simply add here fraud alert, just the object, that's it. Now what is the last step you want to do? What we are doing here, we are writing it to the another topic called fraud alerts. Okay, so what I'll do, I'll just define to where you want to write fraud alerts topic, on which format do you want to produce it, as a string or you want to produce it as a object. I want to produce it as a object, so you can use produced with, again key is same, string studies, and value is what, this one. All good, that's it. Now you can return the stream. Let me remove the previous code. What happened to this guy? Okay, change it to transaction. All good. Now how clean is this code? Only 3 line, that is on method chaining using Java stream. Okay, so things will be more complex in upcoming videos when we will use the windowing logic, when we will use the group by map, flat map, all the methods. Okay, so have patience, let's go slowly one by one. Everything we can digest at one go. Let's understand from the basic, then we'll go step by step to the advanced concept. Now what next? If you remember, in application.yml, as part of the stream configuration, what is the key and value study we have defined? Key as a string, that makes sense, but value, do you want to use the string? No, right? We want to use the transaction object, or we want to use the JSON study. How we can define that? Simple thing, just copy this. Now you just need to change this to, okay, that's it. Looks good now. Now let me quickly start the Zookeeper and Kafka server. Now let's test our application. Let me restart it. Now it seems up and running. Now one thing I want to show in the console, let me search it. Now what is the key studies we are using? String one, right? Now if you see here, what is the value study we are using? JSON. So our key serializer and deserializer is configured correctly, right? Let me clear this. Now let me open the Swagger. I'll just trigger the request. Same, it will trigger 50 transaction object instead of string transaction. Now it will send 50 transaction object. Let's see this. Response is success. Go to the code, see the console output. Fraud alert for transaction. Our stream application successfully able to get the transaction object directly. and filter out the fraud transaction which is exceed greater than 10,000. Now to visualize that, you can see the transaction which will have all the events, all 50 events whatever we have sent. Fraud alert will filter out the transaction which we are sending from code. Okay, looks good. Now we might be thinking, how simple is this? Just define the JSON study, our job is done. But is it really recommended to go with this approach in production? No. I would say this JSON study approach, just defining one line and do the change in your application.yml wherever you are sending the value part. It is good for learning purpose, or you can say for demo or for better readability. But in production grade Kafka Stream application, if you want to achieve the advanced feature, like you want to compress some data, or you want to encrypt it, or you want to maintain the schema evolution, or you want to hide few fields, you don't want to serialize them or deserialize them, then you don't have that control if you will go with this default approach. For that, the approach is straightforward, and that is also recommended approach in real time. You need to define your own custom serializer and deserializer. Then you can wrap those serializer and deserializer to a SUDI wrapper. Okay, I'll show you that. So what I'll do, I'll just create another package. Now here we need to define serializer and deserializer. That is plain Java code. I am not going to write it. I will just copy paste, and you can understand by seeing the method signature. Paste it. Now see the code. I have defined something called transaction serializer, who will convert input object to the byte array at the time of serialization when you send the event to the topic. Okay, that is what the basic flow, guys. Now what we are doing here, we have created a transaction serializer class. We implement it from serializer who comes from org Apache Kafka. Then we have created a mapper, object mapper, and the method is serialize. What it does, it take the object, write that value as a bytes array using this object mapper. Okay, that is what our intention while doing the serialize. Convert object to bytes, while deserializing convert bytes to object. Now if you go and check the deserializer code, what it does, again we have the mapper, it will take the byte array, then convert that byte array to object using object mapper. Okay, you can use other library as well. I am using this Jackson object mapper. Fine. Now you have your own serializer and deserializer. What is your next step? You need to create a SUDI class for Kafka Stream. So I will define something like this: transaction, and this needs to extend from SUDIs dot, you will find something called wrapper. Okay, and you need to define what exact parameter they are deal with. Now what you need to do, why it is crying, you need to define the super parameter constructor. If you see the message, what it is saying, create a constructor matching super. So what I'll do, I'll do that. First let me create a constructor, public. Now here I'll use super, and then I'll pass my serializer and deserializer to just initialize. Okay, so what I'll do, I'll just use new transaction serializer, new transaction deserializer. That's it. This is the super class, and since we have the super class has argument constructor, while implementing that or extending that, you must need to follow that pattern. That is basic Java, right? You must need to define the super with argument. How many parameters your super class have? All good. We have defined our custom serializer and deserializer. So there is no rocket science. In serialize we are just, not this one, yeah, in serialize we are just converting object to byte array. In deserialize we are just converting byte array to object, and that is what all we gave to this transaction SUDI, because Kafka Stream will not understand this Java class. He will only understand this SUDI approach. Okay, that is the reason we have followed this pattern, and this is really recommended approach in real time. You need to follow this, and again you no need to write this again and again. This is one time logic. So what next? Now let's ask our Kafka stream to use this. Go to your code, the stream package, open it. Now here, how can you tell to your Kafka stream to use the custom serializer and deserializer, whatever we have created, right? Just comment this. Simply tell here, use new transaction. Same thing while producing that to the alert topic, use the same. Now what next? Go to the application.yml. There also you need to tell that, right? You can go to the application.yml and simply as part of the value study, just tell that don't use this, use com.javatechie.scrde, whatever the package you have defined. Then what is the class name? Make sure to define it properly. If you do any spelling mistake, it will cry on startup. And here also in Kafka producer, if you want, you can change it, that is optional. Remove it. You can define the serializer what we have defined. What it does, it just take the object, convert it to the byte array. Not this one, just use the class serializer. This is how you need to define in your production grade code. Let's restart the application to validate whether it is working or not. So it started. Now if you will check for studies, I should see here. What is the value study? Transaction 1, whatever we have defined, this class. All good? Close everything. Now I'll go to the Swagger, send the request again. Let's see whether it processes the data or not. Can you see here? There are few fraud alerts. Let's filter how many are there. 14. Okay. We send 50 requests. Out of 50, 14 transactions marked as a fraud. Now if you go and check same in the fraud alert, you will find few more records. You can see this. Okay. Transaction topic. This is how you can define your custom serializer and deserializer or studies in Kafka stream. Okay. So today we are going to explore different Kafka streams methods, not just in theory, rather we will go with real-time examples so you can truly experience the power of Kafka streams in action. Well, this is the foundation you need for complex data enrichment and streaming pipelines. And guess what? The interesting part, if you are familiar with Java it streams methods, you are going to feel it super easy. The methods are very similar, but it's little tricky to use in Kafka stream world. But don't worry, as always, I will explain everything step by step and show the output as we go. So well, if you can remember, this is the example we did in our last video. And I slightly modified this code to demonstrate all the Kafka streams methods. Now for example, I have added something called transactions.json. I have modified this JSON structure which we are publishing to the transactions topic. Now if you see here, it has transaction ID, user ID, amount, location, type and item as a nested object. Okay. Similarly, I have added 5 transaction hard-coded object in this particular JSON. Now if you go and check the controller class, I am loading this JSON and converting it to the Java object using object mapper, read value methods. This is the private methods. Then what I am doing, I am iterating each transaction, okay, and publishing one by one to the transactions topic. So the reason I keep this structure in the JSON so that I can give you the real-time example of each methods of Kafka stream rather than just giving hello world kind of scenario. Okay, so let's list down all the methods which we are going to demonstrate. Now let me go to the fraud detection stream. This is where we have added our Kafka stream logic, right? Reading from the topic, then publishing to the fraud alerts topic if you found the transaction amount greater than 10,000. Now what I will do, I will just clean up this and I will add a comment here what all methods we are going to understand. So filter, you already aware about it. Filter not, map, map values, flat map values, branch, group by, aggregate and count. See this. Isn't it same as Java stream methods? Yes. But the use case is little different, or implementation of these methods little bit tricky in Kafka Stream. But don't worry, I will explain everything in details. So this is what our existing method, right? What we are doing here, we are reading stream of transaction event from this particular topic. Then we are filtering out all the transaction whose amount is greater than 10,000. Then mark it as a fraud alert. Okay, that is the simple use case we did in our previous example. And what we are used here, filter. What filter does, it filter out the events or the records based on the condition. Fine. And then at the end, what we are doing here, whatever the fraud alert we found, we send to another topic that is called fraud alerts. Okay, so what I'll do, I'll just comment this line for now. Since we are going to explore around 9 to 10 methods, every time sending to different Kafka topic will be time consuming. So for now, I'll just add a peak statement so that you will understand what is the main purpose of using each and every methods. Okay, let's make it simple. In upcoming video, when we will use those methods, you will get the clear idea. Fine. Now, what is the method? We understand filter. It will work based on the predicate you will pass, or based on the condition. If it is satisfied, then it will process that particular record. Now what next? Filter not. It is opposite of filter. It keeps records where the condition is false. For example, let's say you want to ignore or skip all transaction less than 10,000. You don't want to process them at all. So what you can do, you'll write like this: stream, then you have the filter not method. Use this filter not method to not filter the records based on your condition. If it is less than 10,000, just change this number, okay? 25,000. Now if less than 10,000 you found any record, then don't filter them, okay? Just not to filter it. And you can add a log statement saying that, okay, this is normal transaction. Now what will happen? Now if you see the JSON record, the first transaction is of 5,000, 15,000, 200, 25,000, 1 lakh. Now when you will do the filter not, what condition we have passed here? Filter not less than 10,000. Now it will only give you the output of the transaction which is greater than 10,000. Okay. So if you want to test that, what we can do, let me comment this. Already we know this filter and its use case. We already did one example. We'll go with the filter not. Okay. It will not filter any record less than 10,000. The transaction amount less than 10,000. Now I already started my Zookeeper and Kafka server. Let me start the application. So you can see here it started. Transition from rebalancing to running. Okay, let me clear this. Now what I'll do, I'll open the Swagger. Then I'll send the request. Published 5 transaction to Kafka. Now if you see your console, normal transaction for this, see the amount. Does it process any transaction amount less than 10,000? No. If you don't want to filter that particular condition, then just use the filter not. Okay, that is the simple opposite of filter. Fine, right? Now let's move to the next method, that is map. Okay, what this map does, it is again similar to the Java stream. It will help you to transform the data. Okay, so let's say now what we are sending to the Kafka topic, or what exactly data we are getting from our topic. Now if you see here, the key as a, what is the key? Transaction dot id. Okay, transaction id, which is nothing, this dynamic value, correct? And then value as a transaction object. Can you see here? Now what I want to transform the data. Instead of sending transaction id as a key and value as a transaction, I want to send some human readable key and value for my upcoming task. Okay, now you remember the flow. After this, we usually send this data to other topic to process it, right? Now, while sending it, I want to customize my data. I want to send different data, not the same what I am getting from this transaction. How can I transform that? You can use the map method. That's very simple. Let me show you. Comment this first. What I'll use here? Stream dot map. What it will give you? It will give you the key and value. Key is the transaction ID, which is string. Value is what? Transaction object. Now what you want to do? I want to transform this record. So for that, what you need to do? This Kafka stream give you a key value pair similar to the map. You can use that key value dot pair. Inside this key value pair, what you want to set as a key? I want to set as a transaction dot user ID. What you want to send as a value? I want to send some string. User spent some amount. Okay, what is that amount? Transaction dot amount. Something like this. I want to send key as a user ID, not the raw transaction ID which I am getting in the transaction topic, and some value as a string value, user spent amount, something like this. Now just input this. Now what I want to do, I just want to log the statement. Just add the peak. How simple is this? Use the map, convert the way you want to publish the event to your next topic or to your next task. Now this transaction.user ID is my new key and this is what the new value. Now I can send this particular event to the next topic wherever I need. I mean, I'm just giving an example, but you can customize the way you want using this particular map. Okay. Now let me also explain the map value. Then we'll run these two examples at one time. Now what is the next value? Next methods, map values. Now what this map values does, it is again similar to the map, but it won't allow you to modify your key. Map values means only you map or transform your value, which is nothing your transaction object, and that is straightforward. What you can do, stream dot map value, you will find your only value mapper, okay, not the key value mapper. Just use it. What is your value? Transaction, right? You can define this is my value and I want to print some log statement, or I just want to use this as a value, the new value to the next topic or whatever the task you will do. Then I'll simply do the pick. Simple, right? Using map, you have option to modify both key and value, but using map values, you can only modify your value, which is nothing your transaction object. You cannot change key here. So let me run these two examples. Let's see the output, then we'll understand. Okay. So I have commented previous two. Now let's run these two methods. Let me restart the app. So it started. Let me clear this. Go to the Swagger. Send the request again. Published 5 transactions to Kafka. Now go to the console output. See the output here. User transaction summary. What is the key you modified? User ID. User ID is U1. This we did using the map method, where we are able to modify the key. And what is the value? The message you are sending. User spent amount this. Now the second, see the second log statement. This we used using map values. So what we modified? The key will be same. It won't be modified, which is nothing your transaction ID, but only we modified the value. Okay. Similar way, see the third one, which you modified the key. Then fourth one, key is transaction ID. You have only option to use the value because you have used the map values. Okay. So this map values is always faster, or what I can say, it will be always lighter and faster since only the value object is modified. Okay. So it depends on your use case. You need to either choose map or map values. Now let me clear this. Also we'll comment these two methods. Now what is the next method? Flat map. So flat map, I believe you already aware about it. This is very important method in Java stream, and in all the application we widely use this flat map method, right? What this method does, if it found any one to many relationship or nested object, see for example this transaction has nested object list of item, it will help you to flatten this list into multiple records. For example, what I want now, if you'll see the first transaction object, I have one transaction ID. For this particular transaction, I have how many item? 3 item. Now what I want to do, I want to maintain a payload, or I just want to maintain a key value, key as a transaction ID, value as a individual item. Okay, so if you see the first JSON object, I should get 3 object where the key will be transaction ID and value will be its corresponding item. Or you can keep it in simple word, each transaction contains multiple item, correct? I want to emit one record per item for detailed tracking, something like that. So if you see the output, what I am expecting here, something like this. Transaction ID, for this transaction ID, how many item I have? 3 item, 01, 02, 03. So based on the transaction, how many items is there, I just want to emit individual record per transaction. Okay, or you can say individual record per item. That is what I want to do. You cannot achieve this using simple map or map values. Since it has the nested object, you must need to go for flat map. So let's try that out. Now go to your fraud detection stream. What we are going to use? Flat map. Stream.flatMap. You have the key value pair. Key is nothing your string, which is transaction ID. Just use key, and value is your transaction object. Now it is very simple. What you need to do, your transaction has multiple items, right? So get the list of items from transaction, iterate them, then map this particular key. That's simple, right? But to store them, you need a list of, what is that? List of key pair. That is what the Kafka stream used, right? Key value pair. So list of key value of type what? Key as a string, transaction ID, value as a item object. That is what you want to maintain, right? So just define item, and you can give the name, let's say result equal to new array list. You have this result. What you need to do, just create a loop of transaction.item, which will give you the item object. Just define item, you will get from transaction.items, right? Now what you can do, get the each item object, map the key, and store in this particular result. So use result.add. What you need to add? Again, you need to maintain the key value. Key value dot pair. What is your key? Key is nothing your transaction ID. Transaction ID. What is the value? Value is nothing your item. That's it. Now you can just add a peek statement to print it. Usually peek method we used for debugging purpose. In a stream, anything you want to debug, you can simply print it. Here simply return that result first, then just add the peek. Item purchased, this is the transaction ID, which is nothing your key, and item object. Hope you get this. That's what I was saying. In Java stream, it is straightforward. Just convert nested object with .toStream method, right? But here it is little tricky. But don't worry, once you start using these methods, you will be familiar with its syntax and approach. So there is no rocket science. We created a key value list because we want to add a key as a transaction ID, value as a item. And where you will get that? You will get it from the transaction object. So we are iterating it, and behind the scene we are creating key value dot pair, which is similar to the map, and mapping those value. Then here I just print it. Now again at the same time, let me use the flat map values method. Then we'll run both the method at one time. Now what is the next method? That is flat map values. So what we can do, you have the stream, then use flat map values. What argument you are seeing here? Only value mapper. You can't change anything in the key. So what will be your value? Transaction object. And what you need to do? Transaction dot items, right? Then just add a peak statement, because your key will be never change if you are using flat map values. Okay, so you can also change it to the method reference transaction item. So I'm just printing it. Simple, right? Just one line. In flat map method, you have done the iteration because the key can be anything and you want to only map the transaction ID. But in flat map values, you don't have option to change the key. Key always you will get the transaction ID, and value is these items what you want to map, or which is your nested object. That is the reason we have used the flat map. Okay, so I'll also add here to see the result in console properly. This is flat map and this is our flat map values. Okay, now we are good till this point. Let's run these methods and we'll see the output of these two. How we structurize the nested object using flat map and flat map values. Let me restart the application. So it started. Clear this. Go to the Swagger. Send the request again. Go to the console output. Now see the output here. This using the flat map. What is your key? This is the transaction ID and your items. All the items mapped to this particular transaction ID. We created individual event per item. Can you see here? Now this using the flat map values. What is the key? Transaction ID. Okay, item is this. For all the 5 transactions, you will see the output. See here. Are you good here? All good. Let me comment these two. Now what is the next method? Branch. This is really very interesting methods. I will tell you with an example. So if you read this method, this name itself self-explanatory. What it does? It will split a single stream into multiple substream based on condition. For example, if you will see this transaction JSON, I have something called type. This transaction made by debit card, this one by credit card, like this. Okay, what I want to do, I want to create separate transaction by type. Okay, I want to separate debit and credit transaction into 2 different stream. All the debit transaction will go to a single stream, all the credit transaction will go to another stream. Basically I am just splitting this transaction, whole transaction stream into 2 different stream based on the condition type. How can I do that? I can use the branch here. That is again very interesting. Let me show you that. You can use stream dot branch. What you have? You have key and value, right? Key and transaction. You can define transaction dot type. If it is equals, ignore case, credit card or debit. Okay, similarly you will add another condition for branching. Just define credit. Okay, now what I am doing, I am branching based on 2 type, debit and credit. Just close this. Now once you have this, what it will return you? It will return you array of object. Okay, see this KStream of string transaction array, because we are splitting it to 2 different stream. debit and credit. Now what next? Now you have this branch. Get the 0 index, that will be your debit. Get the first index, that will be your credit. So you can do something like this. Branch, this is array, get the 0, then you can add a pick statement. Okay, something like this. Just add it. So branch of 0 will give me the debit, correct? Similarly, branch of 1 will give you the credit transaction. So let me change this serializer. How simple is this? How we branch based on condition, debit or credit. Now in this example, if you want, you can also branch based on the location. Anything you can give a try. What you can do, let's run this, then we'll see the output. Let me clear this. Go to the Swagger, send the request, go to the console output. If you see the output, credit transaction, okay, how many credit transaction we have? 3. And how many debit transaction we have? 2. So better, let's visualize it in Upside Explorer. If you see here, after the stream or after the branching, we are sending it to 2 different topic, right? Debit transaction, credit transaction. Now let's validate the count in this particular topic. Go to Upside Explorer. Can you see? Yeah, there are 2 topic, credit transaction and debit transaction. Go to the credit transaction, 3, correct? These are the key and these are the value. Go to the debit transaction, key and value. We are good here, right? We are able to see the record. That is how you can use branch to stream or to branch into multiple stream. If you have a single stream and you want to branch into multiple stream, then you can go for this particular branch method. Now let me comment this. We are good here. What is the next? Next is group by key or group by. Anything you can say. Let's keep it group by. Again, this is another interesting methods in Kafka Stream. So let's understand what is this group by does and how it work. So before we use this group by, let me do one thing. In application.yml, I will specify Kafka Stream to use that directory as a in memory, create all the partitioning and all whatever you want to do. Okay, because group by does something internally which I will explain in a moment. Before that, I will tell to the Kafka Stream state directory user Java Techie desktop. What I will do, I will create some folder here, Kafka Stream logs, something like that. Okay, usually what happen when you do the group by or when you use any aggregate methods, it maintain the state. So far, whatever the example we have tried, it's not a stateful example. I mean, if you see all the example, we simply get the value and we just print it, or we just get the value and we branch it based on the condition. Now if you will do some stateful example, or if you will do some stateful operation like finding the aggregate or just do the group by, so in that case what Kafka Stream does, it store the state of your event in some in-memory DB. So when I'm saying in-memory DB, Kafka Stream internally use rocksdb. Okay, so to maintain the state. So for that reason, I am telling to the Kafka Stream, use this directory and maintain your rocksdb state in memory to this particular path. Okay, I'll show you. Once we run the example, you will see the data or rocksdb, all the things inside this particular folder. Now we are good here. Now what we want to do, I want to use this particular group by based on a condition. Now if you see my transaction.json, all the transaction has different location. USA, if you see the USA, there are total 1 count. If you see India, there are 2 count, and I guess UK is 1. Okay, China is 1. Now I have transaction for different location. Now what I want to group transaction based on their location for further analysis or my for further task. Okay, how can I do that? You can try different type of example, guys. It's not that I am using the location to group by, you also use the location. You can also use the user ID, right? Based on user, how many transaction he did. You can also go for that scenario. But let's keep it simple. I want to group by location. So what you can do? Go to the code, use stream, then use group by, and what you can do, it accept key value mapper, right? So you can pass the key, which is nothing your transaction ID, value is your transaction object. Now what next? You want to group by location, right? So what you can do, tell to the Kafka stream, hey, I want to group by this location. Now after do the group by, I just want to simply count transaction per location, convert it to stream, then just add the peak. In peak, I will keep the key as a location and count. That's it. What we are doing here? We are doing the group by all the transaction based on the location. Then we are counting number of transaction for that particular location, converting it to the stream. Then key is my location and count. Location XYZ has these many transactions. That is what my goal to print. Okay. So similar way, the way we have published to different topic for different tasks, you can do it here. But I'm just adding a peak to make this thing simple. Now if you see this count, what it return? KTable. What is KStream? What is KTable? All you will understand in details in upcoming class. But for now, just assume KTable is nothing your database. Okay, just assume as a in-memory database. Fine. Now what I can do? Let me restart the app. Now it started. What it is doing? See here. Fraud detection stream, KStream aggregate state store, topic or partition. Okay, let me clear this. Let it complete first. It will do so many things behind the scene. Partition assigned to running. All good. Now go to the folder what we created. Can you see here? Does it create a folder called fraud detection stream? From where Kafka stream took this name or took this value? From your application ID. If you see here, stream application ID we have given fraud detection stream, right? It take that value. Now what is there inside? Yeah, see here. 0 0 0 1 0 2 1 0 like this. Now you will understand again in upcoming class, but let me give you some heads up. 0 underscore 0, the first part is your topology, second part is your partition count. Okay, 0 1, 0 topology, 1 partition, 0 topology, second partition, like that. Inside each task you will find something called rocksdb. Inside rocksdb you will find something aggregate state store, all the logs. If you will not specify this path what I have defined here as a state directory, it will create inside a temp folder. So for that reason I have created this particular path to show you that it's not theoretically only you will say okay it's using something called rocksdb. Reality it is using rocksdb to store the state. See the name, see the file name, you will understand. I didn't explore much about each and every log file what it contains, but at high level I am just giving you the heads up. Okay. Now go to the offset explorer, refresh it. Can you see here? Fraud detection stream change log, fraud detection stream repartition. I'll tell you what repartition it will do. Now if I'll open anything, let's see, is there any record? No, change log, don't have any records. This also don't have any records. Now let's run our application. Okay, go to the Swagger. First let me clear the console output. Okay, all cleared. Send the request. Let's go to the console output. Great. Location UK has 1 transaction. Location China 1. Location India has 2 transactions. Location USA has 1 transaction. Are you getting the correct count? Now let's see the interesting fact. Now if I'll execute this, see this. Now what Kafka stream internally does, it repartitioned by the grouping key. What is our grouping key? We want to group by what? Location, right? That is what we have defined. Now earlier, what is your key? Your transaction ID, and value is a transaction object. Now since you are asking Kafka to group by location, what it does, it create a in-memory store and it repartitioned it. Can you see here? What is the key now? Your location. Based on location, you will find the records. I mean, Kafka stream internally maintain that. So it does the repartition based on your grouping key and maintain the state or maintain the count. Okay, that is what the stateful. If you will not store it somewhere, then how you will group them? That is why it is stateful operation. And as part of the stateful operation, what magic Kafka stream plays, it just keep the key based on your group by. So in simple term, it simply create a temporary internal topic like this. Okay, it create a temporary internal topic, and each record is again repartitioned or rekeyed based on the grouping key what you have provided. I have provided transaction.location, so that is the reason my key is location. If I'll give user ID, my key will be user ID. I'll show you that as well. Okay, so here good here. So you understand how to use the group by, and at least you get some high level context when you do the group by what magic Kafka stream does. Now what next? Aggregate. Aggregate is again an interesting methods, but we'll come to that method in a moment. First let me explain this count. Okay, since you just understand group by, it will give you a clear picture to understand count. Again, count you can consider as a stateful operation. Now what I want to do, I want to count the number of transactions per user. Let's take this simple use case. What I want, what you did here in previous example, we just find the count of transaction based on location. Now I want to find count of transaction per user. User 1 how many transactions he did, user 2 how many transactions he did, like that. Okay, the reason I am repeating similar kind of example, I will show you something. Now what you want to do, stream. Okay, first you need to group by, correct, based on the user ID. If you can group by, then only you can find the count. Based on user ID, I want to group by, then I will find the count, and I will explicitly tell to the Kafka stream, hey, just create an in-memory store, the name what I am giving to you, and maintain the state. How I can tell to the Kafka stream? You can say, hey, materialize this dot as, give the store name. This is my store name. You use this particular store name, maintain the state, give me the count. Every time a new update came, you also update the state in your store and give me the updated value. That you no need to take care about it. That will be handled by Kafka stream. Okay, then simple. Once you have this, convert it to the toStream. Then again, you can add a log statement. Just add a peak. Simple, right? In count, here if you will not specify anything, Kafka stream will create its own materialized view to maintain your state. But you also have an option to tell to the Kafka stream what store name you want to keep, where your Kafka stream will maintain the state. Okay, now let me run this. Now if you, okay, it started, but now if you understand the previous example, at least you can answer me now. Now what will be the key maintained by Kafka stream? Here if you observe, it maintain the key as a location, because that is what I ask Kafka stream to group by. Now here, based on what field I am doing the group by, user ID. Now Kafka stream will maintain key as a user ID, and segregate all transactions specific to that user, store the count in this particular place or in memory store. Okay, now let's go to the Swagger, execute the request. Let's see the console output. Now if you see the output, user 2 made one transaction, user 1 made two transaction. Okay, and user 3 maintain 1, user 4 1. Now same, if you'll validate here, let me refresh it, you'll find something called fraud detection user transaction count store change log. Now if you see here, what is the key it is maintaining? U1 2 3 4 user ID. In earlier it maintained the location because that is what we group by. Now it maintain user ID. Internally Kafka Stream does this repartition based on your grouping key or based on your aggregate method condition. Okay, now same thing, if you validate here, can you see here in rocksdb it created one in memory store to maintain state for your operation, because that is what I explicitly tell to the Kafka Stream to materialize or use this particular store. Okay, we are good here. Now let me comment this. Let's move to the next method, that is aggregate. What this aggregate method does, it will help you to do the custom aggregation like counting, finding the sum, finding the average, or any complex computation. Okay, for example, in my transaction I am using different type of card. Okay, I want to calculate the running total amount spent for each card type. How many total amount spent using credit card, how many total amount spent using debit card. I want to find out a result of it, the counting sum. If in real time you'll keep getting the transaction events of different type, your Kafka Stream will create the meta store or the in-memory store, and it will keep update and give you the latest value. We want to calculate the running total amount spent per card type. I want to get that aggregate result. So I can go for this aggregate method. Okay, how can I do that? It's very simple. You have the stream, but before I use aggregate I need to use the group by, right? Group by what? Based on the card type. Okay, define key, value as a transaction, and condition transaction dot type, card type. Okay, then you can use dot aggregate, initialize the first value, that is 0, then this value will update. Okay, then what is the parameter? Do you know the reduce method? It is similar like that. Okay, but reduce method will always return the same object. Here you can customize the return type. Let's say your upstream is giving transaction. If you will use the reduce, you must need to return the transaction object. But if you will use the aggregate, it will aggregate and give you the result, the value or the type you want. Now the parameter I will define type, transaction, and current value. Now how you will find the current sum? It's very simple. Just use the current sum. What is the previous amount? Transaction dot amount. That's it. Now just define how you want to materialize it, or where you want to store this value, or which format you want to return it. So you can simply define materialized with, what is the key? You can use the SERDIS dot toString or string. What is the value? Value I want to use as a SERDIS dot double. Then just convert it to stream. Fine. Then just add a log statement. Pick card type, this running total amount, type total. Simple example, right? So let's run this application and we'll understand it. Let me clear this. Go to the Swagger, send the request, go to the console output. Now see the output. Card type debit, total running amount 5200. Card type credit, total running amount this much. Okay, so if you want to get the running total amount, which is purely a stateful operation, then you can directly use this aggregate method. There are many more methods, guys. I'm just highlighting the key methods which we'll use in our upcoming example. Okay, so there are also an interesting method called windowing by, or there is something called join. These are very interesting methods. I don't want to make the things complex at this moment. You first understand these methods. Those methods we'll use in our upcoming class. Fine. So what it does, every time it look into the rocks db, find out the current value, and if it get any new value, it will update here. 5200, let's say you get another transaction of type debit of amount 1000, then it will just add here plus 1000, which will be 6200, and again it will write it back to the rocks db, which will act as a in memory state store for your Kafka stream. So I believe now you will enjoy this Kafka Stream series because we are moving into the real time approach. Kafka Stream is not meant for reading or writing. The actual magic started from here. If you understand all the methods, it will definitely help you to play with Kafka Streams in real time. Okay. So, well, today we are taking things to the next level because this time Kafka Stream is not just processing your data, it's remembering. Yes, we'll be talking about stateful processing where Kafka Streams actually remember past data using RocksDB. Okay, so let's consider one real time use case. Imagine we are tracking user transactions, and within every 10-second window, if a user did more than 3 transactions, then we'll flag it as a potential fraud. So if you consider this particular use case, we have 3 user and user 1 did 3 transactions within 10-second window, and other user did multiple transactions but that didn't fall under 10-second window. That is the simple and practical use case, right? So let's jump right in and see Kafka Streams in action. I hope you are clear with the use case. Let me reiterate, because without knowing the use case, there is no sense to apply the logic. Okay. Now, for example, we have 3 user 1, 2, and 3. Now, if you see here, I have a 10-second window slice, 0 to 10 second, 10 to 20 second, and 20 to 30 second. Now, this user 1 did 3 transactions within 10 second, that falls under 0 to 10 second. Okay, then one transaction between 10 to 20 second, two transaction between 20 to 30. Then this user 2 did total 4 transaction, but 0 to 10 second did 2 transaction, 10 to 20 did another 2 transaction, and this user 3 did total 3 transaction. Out of 3, 2 falls under 10-second window. But our goal or our use case to detect the fraud alert if there are 3 transaction count within 10-second window. So this user 1 is the fraud who did the 3 transaction within 10-second window. But in real time, the threshold might be more. It may not be 10 second, it might be 5 minutes or 10 minutes. For demo purpose, I am keeping it as a 10-second threshold so that we can easily demonstrate the flow. All good so far, right? Let's go to our IntelliJ idea. So we'll be reusing our existing fraud detection system. We'll add new logic for our current use case. So I would strongly suggest you, if you don't know how Kafka Stream works, how to process the data, how to play with all the stateless methods, then I would strongly suggest you to check out my Kafka Stream playlist. Once you understand that, then come back to this particular video. So let's not modify our existing code, let it be. Better I'll just comment it out, and then we'll create a new stream class to do this windowing logic. I'll name it transaction window stream. Then let me annotate @configuration, enable Kafka stream. Then for logging, I'll add SL4J. Okay. Now the approach is straightforward. Usually in Kafka stream, what do we do? We read from source topic, process the data, then write it back to So to read from the source topic, what is our source topic? That is transactions. Once you read from the transactions, what you want to do? We want to apply windowing logic, correct? So that every 10 second, if we found 3 transaction or more than 3, then raise a bar as a fraud alert. That is the simple use case. Once you found that record, just write it to some different topic, something like transaction. That is the simple use case we are going to do. But you need to understand this part, how we are processing or how we are doing the windowing. Okay. The first two part, source topic and write it back, that is the basic step of Kafka, which I explained in my second video itself. So let's understand how we can do that. First, we need to get the data from this transactions topic. So I will just copy the code from here. Just add it here. Next, you need to build the logic. You have all the transactions. Now what you need to do? Now remember this particular image. First, you need to group by user and their transaction, right? So that you will find, okay, user 1 did this many transaction, user 2 did this many transaction, user 3 did this many transaction. So once you group by, you will find user 1 5 transaction, user 2 3, like that. After that, you can apply, okay, user 1 had 5 transaction. Is out of that 5 transaction, any 3 transaction falls under 10-second window? If yes, that is the fraud alert. Simple core Java logic, right? Let's do that. So you have stream with you. Just do the group by. You will have key value mapper. Key is nothing your string, right? And what is the value? Value is nothing your transaction. Now based on what you want to do the group by? Based on the user. So just define transaction dot user id. Okay. Then what next? You also need to define the studies. Okay. So you can define grouped with what is your key string dot string, and what is your value? That is your this one, new transaction studies. Just define this. Now what it will return to you? Something like this. User 1 did 5 transaction. User 2 did 3 transaction, like that. That is what you are doing the group by. User 1 and their count of transaction. Okay. Now what next? Next, once you get the count, then you need to apply your windowing logic. Dot windowing by, what is the window time you want to specify? 10 second, right? So you can define time windows dot of size with no grace. What is the duration you want to keep? Duration of second. You can keep minutes as well. Okay. For demo, I am keeping it simple. Is this clear so far? That is a simple logic, guys. Okay. Next, once you have this count based on the windows, what you want to do? You want to ask to the Kafka stream, hey, can you do me a favor? Can you count it and store it in your rocks DB, or create a temporary topic and store it for me so that I no need to play with the DB? That is the whole reason we are using Kafka stream, right? Otherwise, same thing you can do using your database in memory storage. Rather, I do it. I am asking Kafka stream to do on behalf of me. So what I will say, okay, can you please materialize as, give the string where you want to store it. I want to store in user transaction count window store. Okay, once you store it, just convert it to stream. Then it's simple. You just use the peak to write the log statement. Okay, so let me add the peak statement here. I'm not doing any rocket science here. In peak, I'm taking the windowing key and count, and I'm just printing, okay, this is the user, this many transaction count, and timing window. That is what the slice we have defined for 10 seconds. Okay, that is what I'm just capturing here, start time and end time. And then I'm just checking, okay, if count is greater than 3, then raise a fraud alert. And what I want to do next, see the flow. You read from the source topic, you process the windowing logic, then I want to write it back to the transaction fraud alert topic. Okay, so for that, what you can do, you can simply define, okay, I want to write it to which topic, you can give any topic name. Then how you want to produce the data, I want to produce with Windows service. This is what the time window, okay, which will be displayed as a binary format if you are using any tool, and count. Okay, that's it. Now let me return the original stream. Now see this logic. Now tell me honestly, will you able to achieve the same thing using plain Kafka consumer? Those who are thinking yes, just let me know in a comment section. I don't think we can do it with the straightforward approach. You need to take lot many headache. Now here, Kafka Stream is doing everything for us. We are just telling him what steps to execute, and rest thing will be handled by Kafka Stream itself. Don't worry, I'll show you while executing this code. There are lot many things Kafka Stream is doing behind the scene. Okay, so we have this stream logic now. Why there is error? Okay, let's add one more. That's it. Fine. Now let me define a controller class or controller method who will publish random user transaction event. Then only this stream will get the transactions details from this topic and execute the logic, right? So what I'll do, I'll create another controller class, or I can even modify the existing one, but let's create a new one. Let me add it here. Okay, so very simple logic, guys. What I'm doing here, I took a list of users, user 1, 2 and 3, some different location, okay, India, USA, UK, China, and types. I mean, that is just to populate the value. You focus on these users. And I'm keeping a loop, and within that loop, I'm sending multiple objects. Okay, so it might send 7 event for u1, it might send 2 event for user 2, or 0 event for user 3. That is what randomly I am publishing the event to the Kafka topic. So just input this item as well. All good. Okay, sending it to the topic. And just to simulate the flow, I am taking the pause of 1 second. Now what I'll do, first let me start the zookeeper and Kafka server. Zookeeper, then start the server as well. Now since both are up and running, let me start the application as well. Now meanwhile, I'll go to the application.yml file. Now if you remember, see here, if you remember, what is the state directory we are giving to the Kafka stream to maintain all the rocksdb related metadata? This is the folder, right? Users Java Techie desktop Kafka stream logs. So let's check that particular folder. It created so many folder. Now let's see, are you seeing the window? Yeah, user transaction count, window store. That is the same materialized view we are giving to the Kafka stream. Can you see here? User transaction count, window store. That's what something handled by the Kafka stream. It will store user and their count based on the 10-second window slice. Okay, and then it will emit the event, or it will just detect the fraud alert as per your logic. Let's clear it. Go to the Swagger. Now go to this particular endpoint, try it out, execute the request. Come back to your console. See, it's keep publishing the event. It will publish 15 event. It's still publishing. Finish sending transactions. Once it finish the sending, all the logic will be executed. Now if you see here, are you seeing any fraud alert? Not yet. So if you see here, user 1, 2, 3, 1, you are seeing multiple transaction of user 1 and user 2, user 3. But we are only marking as a fraud alert if count exceed 3. Now if you see here, user 1 did total 2 transaction within 10-second window, within this second, 30 to 40. User 3 did only one transaction within 10-second window. It might did 100 of transaction, but within 10-second window we found only one transaction. Others are in different window slice. User 2 also one. That's good thing. Now what we will do to validate this, let me resend the request. You will see multiple transaction. It is keep updating the value. It is keep getting the count. When it first time check its own rocks DB, it found okay, user 2 has a count 1. User 2 has a count 1. Then it keep publishing the event, our producer. I mean, it's just parallel job, guys. Your producer will keep sending event to the topic. At the same time, your Kafka stream will look into the topic and process the data. That's how you are seeing the log shuffling here. Now see here. Did you see the fraud alert? User 3 did total 5 transactions within this 10-second window of 40 and 50. Can you see here? Now, user 1 did 1 transaction, user 2 did total 4 transactions. Go with always maximum number. See, here also you are seeing user 2 did 3 transactions. And you are seeing another number, user 2 did 4 transactions. At first time, when my stream, Kafka stream, read the rocks DB or its metadata, it see the number is 3. Then it will keep update it. Okay, that is how you are seeing the different number. Now see here, user 2 made 4 transactions within 10 seconds. User 3 and 4, we catch them as a fraud alert. User 1 is safe. Okay. Now think technically, if you are going to do the same thing using plain Kafka consumer, how difficult it to handle. Now if you see here, let me show you. Let me open Offset Explorer. Now if you see here, we have fraud alerts. Don't go with that, that is the existing topic. We have transactions topic. Here you'll find all the transaction event. And what is our key? We are defining key as a user ID, not transaction ID. Okay, we have the key as a user ID. U3 event will go to a same partition, U2 will go to different partition, U1 will go to another partition. Okay, that is the reason I have defined the key as a user ID. So it's very crucial to decide what you need to keep as a key while publishing the event to maintain the order. Okay, now if you see here, we have something called repartition, store repartition. If you will execute this, you won't see any data because already we are sending the key as a user, and this repartition will always shuffle your key when you are doing the group by. See here what I am doing here. At first place, stream dot group by user ID. User ID, I am asking Kafka stream, hey, you create a partitioning topic or repartition topic, keep user ID as a key and map their count. However, while receiving the transaction details or while publishing the transactions events, we are already sending the user ID as a key. So this partition topic you are seeing the empty now. If you will change the key while publishing the event and then you will do the group, you will find the records here that we already validate in our stateless methods flow. Okay, so you can double check that. Then there is something called change log. Now if you will see here, you won't able to read it, but see here, key is nothing your u1 u2 with the timestamp 10-second window. It is in the binary format. That is the reason we are not able to visualize it. Okay, so what it does, this change log maintain the slice of 10-second windows. See here, user 1 30 to 40 seconds. For example, let's consider user 2 10 to 20 seconds. Like that, it maintain the key, and based on that key, it maintain the value. Currently value is not displaying here because it is in binary format. Okay, if you will try to consume through Kafka consumer console, you will able to visualize the number. Fine. Now if you see here, this is what our destination topic. Let's run it. Here also you won't able to read it. It is in binary format. That is what we are sending here. See what we are sending here as a key, time window study form. That is the reason what it contains, your user ID and time window. You do one thing, instead of read here, publish the event, consume it, you will see the number. Fine. This is what how Kafka stream handle the windowing logic. There are different windowing logic in Kafka Stream, sliding window, fixed window. There are many more. Okay, don't worry, I will cover them in my upcoming videos.